What is nano? A man's beard grows 5 nanometers every second. Oh, suffice it to say, a nanometer is very, very small. Despite its size, you can see the effects of things happening at the nanoscale all around you. They give the sunset its red color, allow birds to navigate, and help geckos stick to trees. But it's only recently that we've actually been able to see down to the nanoscale. This is nano2. We humans are strange creatures, aren't we, if we're honest? We like to measure things. Earth's tallest mountains are over 8,000 meters tall. A football pitch is around 100 meters. I myself am about 2 meters when I'm standing up, in shoes. Good afternoon. Ants are a few millimeters long. Skin cells about 30 micrometers. We can't see things this small. A bacterium is about 2 micrometers. Smaller still are viruses and phages. And so we go down to DNA, our molecular blueprints. DNA is 2 billionths of a meter in diameter, or more conveniently, 2 nanometers, the units that we used to measure the building blocks of everything. Welcome to the nanoscale. The nano world isn't just unusual looking, things behave differently there too. One reason for this is surface area. If you take a cube and lay the surface flat, you can see how much of that cube can react with the outside world. If you divide the same cube into 8 little cubes, the surface area is twice as big. If you keep making smaller cubes, the surface area becomes immense. More surface means more area for reactions. This is why powdered sugar dissolves faster than sugar cubes. Big lumps of aluminium are not very reactive, but nanoparticles of aluminium are so reactive they can be used in rocket fuel. Light also behaves differently as you head down to the nanoscale. White light contains all colors. When particles get really small, they start to bounce only certain colors back, so you see them as those colors. As gold gets smaller, it stops looking gold and instead reflects red, purple, blue, and finally becomes invisible when it's too small to reflect any colors of light that you can see. Life has spent 3.8 billion years finding clever ways to use the nanoscale. Now we can understand nature's nano secrets. We can use them for ourselves. Looking around the natural world is a great way to pick up ideas for things to make ourselves. But with nanotechnology, we can make new structures that nature has never even tried. Down at the nanoscale, things are gloopy and there's lots of friction. This means particles stick together really easily, and if this happens again and again, new and complicated structures can be formed. This is called self-organization. Scientists have been carefully experimenting with different conditions to see what sorts of new nanostructures they can create. The results are astonishing.